Hey everybody, so we are on to a new chapter which is covalent bonding. If you remember chapter 7, we talked about ionic bonding, which was bonding between a metal and a nonmetal where they transferred electrons. While covalent bonding is a little bit different. Covalent bonding is bonding between a nonmetal and a nonmetal where they share electrons. So with ionic bonding, they were transferring electrons and it was between a metal and a nonmetal. With covalent bonding, they're not hogging electrons, they're sharing them. They're sharing them between two nonmetals. And if you remember on our periodic table, we have our stair step. And if you can recall, things on the right side of that stair step are nonmetal, and everything on the left side is a metal with exception of hydrogen. Hydrogen is also a nonmetal. So you're going to be seeing things bond together like CO2, which are two nonmetals, things like H2O, which are two nonmetals, and things like CH4, which are composed of two nonmetals, carbon, hydrogen, hydrogen, oxygen, carbon, oxygen. So that's what we're going to be dealing with today. And our goal for today is to draw Lewis structures. What are Lewis structures? Lewis structures are molecular representations, or I shouldn't say molecular, they're structural representations of molecules. So at the end of the day, you're going to be able to look at a molecule and be able to draw what it would look like if we could zoom in on it with a microscope, a super powerful microscope. So at the end of the day, you're going to be drawing things like an H2O molecule, you'll be able to draw a methane molecule, you'll be able to draw a nitrogen molecule, okay? And these are good things to know how to do. When you're a chemist and you want to be making medicine, you need to know the size of certain molecules so that you know which pathways they can get through. Are they small enough to get to the brain pathway? Are they large enough to make it through or are they large enough to be blocked from entering certain pathways like your liver or your kidneys? Okay, these are good things to know when you're a chemist. And just looking at these, a couple of basics. When you see a line, that is a bond. Okay, that is a bond between two electrons. So really, it's kind of like two dots bonded together. Okay, so when you see a line, that are two electrons creating a bond being shared. So between this H and O, two electrons are being shared between that H and O, forming that bond. And what you might see are these two dots surrounding like our hydrogen and our nitrogen here. These are called lone pairs. Remember, electrons like to be paired up. They're not going to be by themselves if they can help it. And in these Lewis structures, you'll always see electrons in pairs. You'll never see them by themselves. And these lone pairs are just electrons that are chilling around nitrogen or oxygen or a bunch of other molecules, just making them happy, filling their octet role. Okay? So let's talk about Lewis structures, and let's talk about the rules and how we build these Lewis structures. Alright everybody, here are our Lewis structure rules. Feel free to pause this and write all these down, but while you are writing these down, I'm going to go ahead and talk about these things. Okay, our Lewis structure rules. Rule number 1, we have to count the octet and duet electrons. Okay, octet, most electrons like to have a filled outer shell, and in honors chemistry, for the most part, that is going to be, every element is going to want to be surrounded by 8, except we have a few exceptions. Hydrogen only likes to be surrounded by 2 electrons. That's called a duet rule. Okay, beryllium likes to be surrounded by 4, and boron likes to be surrounded by 6. Everything else on the periodic table likes to be surrounded by 8 electrons. I'm talking carbon, I'm talking nitrogen, I'm talking iron, I'm talking bromine, okay? All the other elements like to be surrounded by 8. So, as far as you're concerned, every element likes to have 8 outer electrons. Hydrogen's 2, beryllium's 4, boron is 6. So that's our rule 1. Rule 2 is we got to count our valence electrons. And remember, our valence electrons are based on what column it's in. Okay, that's the easy way to determine it. So in column 1, lithium has 1 valence electron, sodium has 1. In column 2, magnesium has 2 valence electrons. We skip those transition metals and we hop over to boron. It has 3 valence electrons. Carbon's column has 4. Nitrogen's has 5. Oxygen 6. Fluorine 7. And all those noble gases have 8 valence electrons. Okay. For rule number 3, we're going to take those octet electrons that we discovered, subtract our valence electrons, and we will get our bonding electrons. And you'll see an example of that when we do our first example after I explain these rules. After we figure out those bonding electrons, we're going to divide the bonding electrons by 2. That will tell us how many bonds we have in our whole Lewis structure. Remember those lines that we saw in those Lewis structures? That will tell us how many bonds we have. Okay? 5, we have to determine the central atom of our Lewis structure. Okay? Here is the thing. The central atom is usually the atom that you only have one of. Okay? So something like CH4, the thing that's by itself is usually your central atom. Okay, so carbon's by itself there, it's going to be its central atom. And NCl3, the central atom is usually going to be the one that's by itself, which is nitrogen. Okay, HCl, there is no central atom. Okay, HCl, it's just 2 atoms, so there is no central atom. A rule to remember, okay, a very important rule that is a must, and if you make this mistake, I'm going to be really angry. Hydrogen is never a central atom. Okay? Hydrogen always only has one bond. It's always on the outside of a Lewis structure. Never put more than one bond coming out of hydrogen. Hydrogen will always be on the outside of a Lewis structure. So remember that. Okay? Central atom, one more thing about it. You might have a situation where you have multiple elements that are by themselves, like an HCN. H is by itself, C is by itself, N is by itself. Which one is going to be my central atom? It's the one that's the least electronegative. So if I look at HCN, C is the furthest left on the periodic table. It is the most electronegative. It doesn't attract electrons very much. So as you'll see, when we set up our HCN Lewis structure, C will be in the center. Okay? And last but not least, number 6, we got to draw our Lewis structure and fill the octet. Okay? As you've noticed, I've drawn lone pairs around some of these atoms. Okay? That's because I need to make sure that all the atoms are surrounded by what they want to be surrounded by, which for the most part is 8. Okay? If I look at chlorine right here, it's surrounded by 2, 4, 6, 8 electrons. Remember, the bond counts as 2. A lone pair counts as 2 electrons. Okay, so chlorine is surrounded by 2, 4, 6, 8. That's good because it likes to follow the octet rule. Hydrogen is surrounded by 2 electrons. That's good because it follows the duet rule. Okay, and we'll go more into that when we draw these Lewis structures. So these are your rules. Make sure you have them written down, and let's go to our first example. Let's go ahead and let's start with an example that we've already seen, like HCl. First rule, okay, we count our octet and duet electrons. So I look at each atom and I add up all those octet and duet electrons. So let's look at our first atom, hydrogen. Hydrogen, does it follow the octet rule? No, it's one of those exceptions, right? It follows the duet rule, so I'm going to put a 2 right there. Now let's look at our other element, Cl. Does it follow the octet rule? I look at the periodic table and I say, yes, it follows the octet rule. It's not hydrogen, it's not beryllium, it's not boron, so it has 8. So altogether, I have 10 duet and octet electrons. That is step number 1. Okay? Step number 2, count all the valence electrons in our whole compound. Okay? So I'm going to look at hydrogen and chlorine. I'm going to see how many valence electrons they have altogether. I look at hydrogen. Hydrogen is in column 1. It has 1 valence electron. I go and I look at chlorine. It's over there with those halogens like fluorine and bromine. They all have 7 valence electrons. Okay, that means I have 8 valence electrons all together. Okay, so 10 octet electrons, 8 valence electrons. Step 3, I am going to go ahead and subtract these two numbers. That's why I set it up like this, so I can easily subtract them, right? Octet minus valence electrons for rule 3, that gives me 2 bonding electrons. And what does that mean? The 2 bonding electrons just tells me that I'm going to have 1 bond, right? In every bond, there are 2 bonding electrons, okay? And that's what step 4 is all about, right? I divide this number by 2, and that tells me I have 1 bond. I have 1 bond, okay? So that's what all these steps are doing. They tell us how many bonds we have. You have to follow these steps, okay? So 1 bond, let's go ahead and go on to step 5, which is determine our central atom. We only have 2 atoms, so I'm just going to go ahead and write HCl. Neither of them is a central atom. I'm just going to write them right next to one another. Now we go ahead and draw our Lewis structure. We only include the bonds that we determined in step 4. Okay, there's only 1 bond, so I'm going to go ahead and only put 1 bond there. Okay, don't put 2 bonds because we didn't do the math to figure out 2 bonds. We did the math to figure out that there's only 1 bond, plus hydrogen is only going to have 1 bond coming off of it. Okay? So we filled our bond from our math. Now we have to fill the octet. Okay? Remember, in step 1, we determined that hydrogen likes to be surrounded by 2 electrons and chlorine likes to be surrounded by 8 electrons. We got to make sure that that is shown in our Lewis structure. Okay? If we look at hydrogen, how many electrons is it surrounded by right now? Just 2. Okay, remember that bond is like an imaginary 2 electrons, but we don't draw it as 2 electrons, right? Being shared, we just draw it as a bond. So hydrogen surrounded by 2 electrons, it's happy. But chlorine, it's only surrounded by 2 electrons as well. It is not happy. It needs 6 more electrons in order to have its octet filled. So how do we show or draw those 6 other electrons? We draw them as lone pairs. Okay? So the lone pairs, right? I now have 2, 4, 6, and 8. All right? And now I have 8 total valence surrounding electrons around chlorine. And here's a great thing. You can double check your answer, okay? Count all the electrons in your Lewis structure. 2, 4, 6, 8. That number should match up with the number you got in step 2. So all the electrons you count up should match your valence electrons. If you count those up and they don't match, you goofed somewhere along the way. Alright? Next example. Okay? Lewis structure. That's a polar structure. We'll talk about that next time. Let's go ahead and look at NCl3. Okay, I also wrote that compound down. NCl3. Okay, again, step 1, we're counting all the octet electrons. Okay, nitrogen, does it follow the octet rule? Yes, it does. It's not hydrogen, it's not beryllium, it's not boron. It has 8 octet electrons. Chlorine. Chlorine, yeah, we decided that last time that it follows the octet rule. Okay, but here we don't just have 1 chlorine, we have 3 chlorines. So we have to count the octet electrons for each of those chlorines. So I'm not just going to put 1 8, I'm going to put an 8 for each one of my chlorines. That gives me a total octet electrons of 32. So make sure you're adding up all the octet electrons from each element in our compound. Valence electrons time. Nitrogen, 5 valence electrons. Chlorine, 7 valence electrons. And remember, we don't just have 1 chlorine, we have 7. Right? I add all those up. 21 plus 5 is 26. Subtract these numbers. 6 bonding electrons, that was step 3. Step 4, divide by 2 to get how many bonds I'm going to have. So I'm going to have 3 bonds in my Lewis structure. Okay? If you end up with a number like 2.5 or 3.5 or 1.5, you know you goofed up somewhere and you weren't counting your valence electrons. You should always get a whole number there. A whole number. Step 5, we determine our central atom. It's the one that's by itself. Okay? Nitrogen's by itself. It's going to be our central atom. And it's going to be surrounded by chlorines. Okay? A lot of you guys like to do things like this. Don't do that. Alright? You're not going to see long chains like this unless you go into organic chemistry and you're dealing with things like C3H8, C6, H24, things like that. Alright? So you are just trying to surround a certain atom with other atoms. We're not drawing big lines of atoms. We're just drawing a nice kind of surrounded atom with other atoms. Let's go ahead and draw our Lewis structure. We have 3 bonds. Well, there's only one place I could put these bonds, and it's between these other atoms, right? It's got to be 1, 2, 3 bonds. Okay, make sure you are making those bonds come out of that central atom. All right? Next thing we got to do, we got to fill the octet with those lone pairs. All right, let's focus on nitrogen. How many electrons are nitrogen surrounded by right now? 2, 4, 6. Remember, nitrogen follows the octet rule, so we better put one more lone pair on there. Okay, so now nitrogen is surrounded by 2, 4, 6, and 8. Well, what about these chlorines? Each of these chlorines are only surrounded by 2 electrons. But once again, they follow the octet rule, so let's go ahead and surround them by 6 more electrons to make them happy. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. We now have 8 electrons around each chlorine. Let's count them up to make sure it matches our 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Matches my valence electrons. I know I'm on the right path. Okay? That is NCl3. 2 more examples. Okay, 2 more examples, and we'll move on. P S3 negative. PS3 negative. Mr. Dahmer, what's that negative sign mean? I'll explain. That doesn't come into play until we get to our valence electrons. Okay, but let's go ahead with our rules. Let's go ahead and count up our octet electrons. Phosphorus follows the octet rule. Sulfur follows the octet rule. That's all 3 of them. We have a total of 32 octet duet electrons. Okay, that negative is not going to come into play here. It's only going to come into play with our valence electrons. And you'll see what I mean here in just a second. Valence electrons time. Phosphorus has 5. Sulfur has 6. Had to have 6 for each sulfur. This is where the valence electron comes in. Okay. If you see a minus sign, you have to add valence electrons. So if you see 2 minus, you add 2 valence electrons. If you see 3 minus, you add 3 valence electrons. If you see 1 minus, you add 1 valence electrons. Okay? You'll also see plus. If you see plus, you subtract. If you see 2 plus, you subtract 2. If you see plus 3, you subtract 3, and so on. But since it's minus, we're going to add. That means we got an extra electron. We add up all these numbers, and we should get 24. We subtract them. We get 8 bonding electrons. We divide by 2. That means we have 8 bonds. Step 4 is done. Not 8 bonds. Sorry. 4 bonds. 4 bonds. We're going to have 4 bonds. Okay? Step 5. Determine our central atom. It's going to be that phosphorus that's by itself. And it's going to be surrounded by sulfurs. Let's draw our Lewis structure. We have to have 4 bonds. We have to. When you do your math and it says 4 bonds, you got to put 4 bonds in there. You can't just put 3. So some of you will go ahead and you'll put, Okay? And then you're thinking, what the heck am I going to do with that last bond? Make it a double bond. Okay? You could put that double bond anywhere. You could put it here. Alright? You could put it here. Or you can put it here. It does not matter. Alright? Those are called resonance structures. Alright? But you have to include those 4 bonds. The highest you'll see a single bond, you'll see a double bond, you'll see a triple bond even, but you'll never see a quadruple bond. That's just not a thing in chemistry. Okay, time to fill the octet on these guys. Let's look at phosphorus. It's surrounded by 2, 4, 6, 8 electrons. It's done. It's never going to have more than 8 as far as honors chemistry goes, okay? So phosphorus is happy. Let's go ahead and make the sulfurs happy. This sulfur is surrounded by 2 electrons, 4, 6, 8, 2, 4, 6, 8. Sulfur, that one is surrounded by 2, 4 electrons. So we'll do 6, 8. Let's count up all our electrons, make sure it matches our valence. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We know we're on the right track. So that's PS3 negative. Make sure you're adding valence electrons if it's minus and subtracting valence electrons if it's positive. Real quickly, last one, because I'm running out of time, is BH3. This is a tricky one. I'm going to try to trick you here. Okay, make sure that you remember our octet and duet electrons and those couple exceptions, right? Let's count up octet duet electrons. Boron, is that an octet element? No, it's one of those exceptions. Remember, beryllium likes to be surrounded by 4. Boron, which is this guy, likes to be surrounded by 6. Okay? That's one of those exceptions, those weird exceptions that you got to be aware of. And then hydrogen likes to be surrounded by 2. And there's 3 of those, for 12. Valence electrons time. Boron likes to be surrounded by 3 valence electrons, or likes to have 3 valence electrons, or has it. I guess it doesn't like to have 3 valence electrons, but that's what it has. Hydrogen has 1 valence electron for a total of 6. Subtract those. 6 bonding electrons. Step 4, divide by 2. We're going to have 3 bonds. Determine our central atom, which is going to be boron. We got 3 bonds. They're going to go 1, 2, 3. We got to fill the octet or duet. Remember, boron only likes to be surrounded by 6. So it's not going to have an octet. It's not going to be surrounded by 8. It's only going to be surrounded by 6. Well, right now it's surrounded by 2, 4, 6. Boron is happy. Remember, hydrogen only likes to be surrounded by 2, 2, 2, 2. All those hydrogens are happy. And by the way, if we count up all our electrons, 2, 4, 6, it already matches our valence electrons. Alrighty, those are our Lewis structures, everybody. That is the intro to covalent bonding. Make sure that you're getting practice, understanding these Lewis structures, and having yourselves a great day.